All right. Here we go. Let's look at current events. Here we go. Let's check it out. All right. Let me see if my sound sounds okay. Real quick. Oh, it sounds fine too. I haven't checked that out. All right. What's on current events here? Let's take a quick look. Um, oh, I don't know what these are. What are the two factions of C++? I do not know. Um, let's take a look. Wait, do I know how this works? Oh, here it is. Okay, the dream of a single dialect-free C++ has probably been dead for many years anyway. Where'd my music go? Oh, it's just soft. Okay, not bad at all, says Zero Ranger, I guess. Okay, sure. Um, seems to be a lot of fighting and arguing. The absolute state, I don't want to read the whole thing, but let me just see I just want to know at least what are the two factions. Okay, so Biden wants people to stop. Well, we won't listen to Biden. Microsoft says Rust. Well, we won't listen. We won't listen to big tech. Who will we listen to? We must minimize the need to change existing code. Okay. Automated refactoring systems built on top of Clang. Okay, okay. Yes, you do. I highlighted it. Automated Clang-based refactoring. So is this one of the factions? Okay, relatively modern, capable tech corporations that understand that their code is an asset. This isn't strictly big tech. Any sane greenfield C++ startup will fall into this category, and everyone else. Every ancient corporation where people are still fighting over how to indent their code and some young engineer is begging management to allow him to set up a linter. Wow, that's cynical. Okay, I am almost sorry that I clicked on it because, man, one of those factions sounds pretty bad. All right, let's go to our exorcism login. Okay, let's continue without donating and hop back in here. So I'm wanting to maybe hop through some of these like a little more systematically or something. I don't know. Oh, there's a new one. Man, I haven't been on here in a while. I want to try and grind. Like there are still so many left. There's almost no chance that I'm gonna finish these before the end of the year at this point. I don't know. I mean, we'll see. But here's what I'm thinking. Here's what I'm thinking. For today, I'm just gonna try going through, start at the end, and work through backwards. All right, let's do this one. Kind of nice. This one's a JavaScript, so hopefully, if it's a JavaScript, I won't take forever on it, but we'll see. Armstrong numbers. I'm not sure if I've ever heard of these before. Okay, let's go to Armstrong numbers. Exorcism. JavaScript. Okay, let's take a look at this. What does it say? Okay, pretty simple, I guess. Armstrong number is the sum of its own digits, each raised to the power of the number of digits. Okay, so 9 is because if we take 9 to the power of 1, we get 9. Fair enough. 10 is not because we take 1 to the power of 2 and add 0 to the power of 2 and only get 1. Okay, so let's take a quick look then. So if we are looking at some number and we are using JavaScript, so the number is 10, n equals 10, and let's say a for Armstrong number equals n, well, let's just call it x because I already used n, I guess, and we'll say x2 string, and then let's spread it. and then reduce ac plus e. Oh wait, no. Let's make it into a let's say s equals x2 string so that we have that. So now let's spread s here. Okay, and then reduce ac plus e to the power of s length. Is that what they were telling us to do? So we're summing these, I guess. But this has to be number. All right, and we have to start with 0. And we have to return that. Let's return that. And then, yeah, let's just return the number first so we can look at it that way. But what we have to do is return a number equals whatever, but number equals x in this case. So let's go a(n). So I got 1. Okay, a11. What do we expect to get? 2, right? Okay. a12, we expect to get 5 because 2 square. Okay. This time we expect to get 10. Okay, getting closer. This time we expect to get, what? So this time we do 4 square, which is 16, right? So 17, so we're going to overshoot, right? Okay, so we overshot. So I guess we don't have an Armstrong number with 2 digits. Okay, so do we have one maybe with 3 digits? What if we do 130? 28? What if we do 222? No, that doesn't make sense. What if we do 888? Okay, that's too high. 777. So if there's 3 digits, it becomes a lot more complicated, I guess. What about 2 digits like 99? Okay, so they're interesting. There are a lot of possibilities here. 91. So do you think there's one in the 90s? What is 92? 93? 94? No. Interesting. Okay, so is Armstrong equals x, and then we go a, x equals x. Okay, and so then we're gonna take, let's see, what Armstrong numbers are there in the first 1,000 numbers. So we'll take new array of 1,000, I guess, fill, map, I, so we fill it all up like that, and then filter is Armstrong, right? So we got 1, 2, so all the single digits, so far so good, and then we found 153, 370, 371, and 407. Okay, so let's take a look. So if we do 153, we're going to do 1 to the power of 3, that's 1, okay. 5 to the power of 3, that's 125, right? And then 3 to the power of 3 is 27. So if we add 1 plus 125 plus 27, are we going to get 153? We do, right? And so similarly, these others, I don't know. So it's, I mean, I guess that's the solution already, basically. Let's take a look at now what we're going to do here. So let's see if we can, npm I first is probably necessary here. And then we'll try, see, I mean, these puzzles are very easy, right? The trick is, can we do it in all the programming languages requested, right? Because for this one, like, we're going to do it in JavaScript, easy enough, right? Because do I know JavaScript? I mean, yeah, kind of. But then we have to do it in D, and then we have to do it in MIPS. I mean, it's still an easy puzzle regardless, but have I ever touched or attempted to do anything with the D programming language? I have not, but I'm going to here tonight. Okay, so let's try running the test. And it says, failed, throw error, remove this statement, and implement this function. Okay, so since I already basically did it, I'm just gonna copy whatever it was that I had here, right? That's, I guess, most of it. So copy, and then we're supposed to put the code into where? The JS file, Armstrong numbers JS file. Okay, so this is not good. So let's put this instead. This is perhaps better. Okay, so hold on. Okay, so now the linter is going to complain. Fair enough. So, sorry, let's say const s equals x to string. Let's put x in here. And then let's put this on its own new line, I suppose. So we were going to return, this is spread, and I mean, yeah, I think that's good. I'll just put this on its own line, and maybe this on its own line. And I mean, so now we have to do x equals, and that's it, right? So now let's try the test again. Okay, so it passed one, so let's turn on the remaining tests. Let's go into the spec file. And it says x test, so we are going to go substitute x test wherever it appears with just test everywhere, run again, and 9 passed. Okay, so let's submit. So, I mean, I feel kind of okay about that just for the fact that I didn't spend forever on it. And I shouldn't have, because it's a very simple question, right? All right, so let's take a look. All right, so now hopefully I won't spend forever on it in the D programming language. We'll find out. We'll find out how it goes. Okay, cool. All right, so let's close there, and now let's look at it in the D programming language. Join the D track. All right, so we're going to start with the hello world. And let's see. No, we're going to start with install the tooling, excuse me. Okay, so the most recent compiler version, Digital Mars D. Okay. We can use homebrew. Let's do it, baby. Looks like a winner to me. Let's see what it does. Uh-oh, outdated formula. Digital Mars D compiler. Okay, cool, that was easy. So now, does it say anything else? IDE support. We'll take a quick look. This looks like a nice. I like that they use MediaWiki. It looks beautiful. All right, where's Vim? Right here. D in Vim. Is one of. Hold on. I'm not gonna worry about that for now. I may come back to it if I'm having trouble. We'll see. Prerequisite dub. Okay, hold on. So we did DMD dub, so we need a dub. Okay, let's try this. Let's see what it does. Dub. Dub. Okay, that looks like a winner. Okay. So, good. Okay, so that's the end. Let's try the hello world. We're going to go to the D programming language. Oh, yeah. All right, so. Let's try running the test. Let's see what it says. Cannot find input file. All right, let's take a quick look at the help. It says you can run the tests, dub test, Oh. Huh. Okay, cool. Um, does this... I'm a little bit of a mess right now. Okay, let's see how this goes. Um, failed to set dynamic section sizes? That doesn't sound good. Okay, so we tried dub test. Get the first test compiling, linking, and passing. Sure. Okay, well, let's take a look at our source file. Okay. All right, so this is nice. The test is right here in the same file. Okay, so it still says something bad, I think. Um, is this what it said before? Before it said failed to set dynamic section sizes. It still says that. Okay, right here. Failed to set dynamic section sizes. Okay, let's take a look. I don't really know what that is. We'll see. Is this what we need to do? I feel like I don't necessarily think so because this is about C++, and I have been using C++ a bit and it's been working fine. Here we are using D. So let's put D. I don't think this is going to help. Oh wait, what is this? No, this is not it. Shoot. Okay, so let's look at dwiki. Dwiki, okay. Okay, dlang. The D, well, let's see. Getting started. Let's take a look at getting started. Um, okay, let's try running the file maybe with dub. So dub source. The source file must start with a recipe comment. Okay. And is this whole thing the recipe comment, or is it just this? I'm not even sure. Let's try this part. Whoops. There it is. User bin env dub. Okay. Okay. So the rest of it said dub SDL name color test dependency color. Interesting. Because that's a little bit different, right? Because here we just have this string hello and this unit test, right? Which I think seems nice. Okay, let's get rid of that again. And okay, dub test. Does it say specifically that it did find our file? Okay, so when we do dub test, we can put package options application arguments. Okay. So do you think we just put maybe the package name? No, this says module hello world. So module and package. Let's see. Hold on. Code troubleshooting. Wow, talk about making excuses. Okay, let's see if we can make this work. Oh, nice. That's cool. Oh, programming in a D for basic programmers. Nice. But we don't have one for JavaScript programmers. No. No. Okay. Let's okay, hold on. Oh, let's search on the wiki for what happened. So it says failed to set dynamic section sizes, right? Now this is coming out of LD. To be honest, I don't remember what LD is at all. I know I've seen it. And this should be the same thing I just brought up, the GNU linker. Okay, okay. Failed to set dynamic section. You know what? Hey, let's just try it with one of the alternative compilers they suggested. Let's try LDC next. I keep doing them. LLVM at 18. I guess that's not a version we already had. Darn. All right, we'll see how it goes. Okay. So we tried dub. Oh, let's look for the one we just did, which is LDC. LDC. Portable D programming language compiler. Okay. I mean, it sounds like it could be, should be a winner, hopefully. We'll see. I doubt that it'll give this same linker issue, but we'll see. Failed to set dynamic section size was bad. Ugh. Yeah, let's just try a different compiler. Package install LDC on Android. Interesting, interesting. LLVM based D compiler. All right. So are we still waiting? It says 100%. What else should we learn about the D programming language? What C++ wanted to be, which is a better C? Well, darn. Right. Rapidly reaching stable specification and implementation. Okay, okay. Should we take a look at the book? The D programming language book? Whoa. What the? What else? Oh yeah, why program in D? Let's learn. Hold on. Videos, articles. Let's look at let's look at script fan. Since D provides type inference, high-level constructs, and fast compile time, it is a great language for writing scripts. The first line of the file is ignored if it begins with the shebang, and combining this with RDMD, which handles dependency resolution, D becomes a leader in native code scripting languages. Oh, okay, cool. That sounds nice. So they put RDMD here. We put a main, and then we just do whatever. Okay, cool. All right, so we're good here. Okay. So I think we do need dub still regardless. So let's brew remove the other one, which was DMD, right? Or something Mars. Okay. Let's try this again. So dub test, it's set. Oh, hey, that's more like it. All right, so we'll stick to this compiler. All right, let's go to the exercise. Oh, well, let's submit this one first. Exorcism submit. Source. Okay. So that will finish up the hello world. What's this? Community, mentored. Okay. All right, so let's return. And all right, let's close all these. Okay, back we go to the D programming language, Armstrong. Okay. Here we go. Okay, so let's try dub test. And it says, no return statement is expecting to return a value of type bool. Okay, so let's go in there. It's such a simple problem. Hopefully, we'll just... Oh my gosh. Okay, so the whole unit test is here. Cool. Pure bool is Armstrong number, immutable int number. Okay, so if we recall what we did in the JavaScript version, I first did sort of this I to A type thing or whatever. So let's see. So we know we have an int. So let's look in the dlang wiki. And let's look for int to string. That way we'll do the same thing as we did in JavaScript. That would make sense. Because, I mean, it was a pretty fast way to solve it. Like, I don't know if it's the most elegant or the prettiest or the most efficient, like, solution, but, I mean, it sure was quick for me to code it in JavaScript. Pretty quick, pretty quick. Is the search a bit slow here? It happens. Hit me with it. Where is the answer? Oh, man. Oh, man. MediaWiki can be kind of slow to search in general. Am I making that up? Probably. Okay, let's try this. Main page. Is the D-Wiki, like, really the place we want to be? Where's the D programming language API or something? Oh yeah, here we go. This looks more like it. Okay, yes. This looks more like it. So int toString. Okay, so let's just say number toString. No property toString for number of type immutable int. Darn. Okay. No property toString. The usual way of using it is via standard format format. Okay. Int toString. To decimal string? Should we try that? Okay, so no to decimal string. Okay, so we can convert it to digits some other way, and I'm leaning towards doing that next. So, okay, so we would just say int x equals number while x greater than 0. They're all greater than 0, right? Okay, so while x greater than 0, then we say, I guess we want an int array. Or more like a vector. Do we have like a vector? Yeah, something. No, simd vector. What simd? No, it doesn't need to be simd. It's more like a list or something. A list, a dlist. List is a complete singly linked lists of pointers or integers. Huh, okay. Well, that sounds okay. That sounds like it might be okay, I guess. Or do we want, let's see, associative array? I want like what is the word? And a resizable array, dynamic array. That's what it is. Shoot. Our collections? Do we have collections? Num collections? Okay, hold on. What is here? Big int array. Okay, how about array? In a newly allocated dynamic array. Oh, that sounds like a winner. Oh, okay. Let's do like that, I guess. Does this need, what does this mean here? I'm not going to worry about it. I'm just going to copy this exact thing for now. Auto A equals array. Okay, well, I don't need these, so let's remove those. Sure. And then when we put things onto the array, let's see. It said dynamic array, right? So we should be able to like add things to it, to the end of it, right? I think. Oh my gosh. Appender. join, replace. Okay. Ender. In place. Replicate. Split. Uh-oh, what's squiggle equals? Squiggle equals just puts things on it? Oh, what? Okay, hold on. What about operators? Initialization? Appending. The squiggle equals means append. Oh my gosh, that's amazing. Okay, great. I love it. So while x greater than 0, a squiggle equals, so a append x mod 10, all right, and then x divide equals 10. And that gives us all the numbers, all the digits, right? Okay, so now, okay, so we won't do that. Okay, so, okay, now let's print that to see where we're at. And then at the end, let's just return true. What's the print? It was, I definitely saw it. I can't think what it was. Hold on, let me see. It was... They showed something here. Uh-oh, is this gonna open? The poor D-Wiki doesn't want to open anymore. Ah! I don't know if I must have done something wrong, I guess. It's all 502 proxy error. It's pretty messed up. Okay. So in the introduction, we have all this. Okay, lexical, types, properties, attributes, contract, portability. Okay, let's just go one by one, maybe. Ooh, get a load of all these. Hey, that's cool. That's a good amount of operators, isn't it? Nice. And they can all be overloaded. That's amazing. Okay. Have I scrolled? Oh my gosh. Okay, I might have scrolled past it. Let's see. Interpolation expression sequence. Okay, okay, cool. And it was in the wiki that I saw it, and now it won't load anymore. Okay, grammar. Man. Oh wait, oh it's right here. Okay, right line. So let's just do this. Okay. Thank goodness. Pasto. Wow, that was a really weird way to say it. So right line, sure, but let's just right line A. A. There we go. Okay, let's see what it says. It says array is not defined, import standard array. Okay, cool. Import standard array. Is that what it said? Yeah. Okay, so it says pure cannot call impure function right line. Oh. Ah, the scandal. Okay, I'm gonna make it not pure then, I guess. Is that better? Maybe. It says performing unit test. Okay, fair enough, but I just want to run the file. Can we just run? Must start with a recipe comment. So, like, I think we need, like, a main file, a main to run or something. I don't know about the recipe comment. Oh, wait a minute. What about using the RDMD? So RDMD is a companion to the DMD compiler, but I don't want the DMD compiler. It messed me up. So do we have an alternative to the RDMD? RDMD. So this one. So I don't know if they have, well, let's see. They have LDC, D runtime. Shoot. Okay, no, we don't want to do. It didn't work before. Okay, so the source file must start with a recipe comment. So let's look up at the recipe comment somewhere. Shoot. It's not in spec. Where would it be? Entire site. Shoot. Okay, let's see what it says. rdub is a front end for dub. Okay, I need a sec. I've been trying to figure out where I put my water. It's here somewhere. Right here. Okay. All right. All right. So I want to see what's in the array to like check my progress so far, right? That's why I tried to print it out. But I'm not sure if I'm going to see it printed out when we run the unit test, because I don't seem to see it here, right? So what we could do is make it into a separate function with its own unit tests, right? Probably more work than I maybe wanted to do, but let's just see. So I'm gonna say we have an auto. I don't know if I can do auto on a function, but let's just try. So int 2 digits, which takes immutable int number. Okay. And then whatever we did here will be part of that, right? And we won't write that. And then we will return A. We won't write line. We can probably make this one maybe pure. It probably should be pure, maybe. Okay, so now let's add a unit test for this. So unit test. Um, so we want to say assert. Can we do equals with an array? Okay, so we're going to say auto expected equals array 1. Auto actual equals int 2 digits 1. And then for int I equals 0, I less than actual length. Do you think that's like what it is? Documentation, language, arrays, dynamic. Okay. And then length. The length property can be set. Okay. I++ assert expected I equals actual I. Yeah? Okay. And then let's assert expected length equals actual. Can we test like that? Let's see. It says okay, array is not defined on 18. Let's take a look. Okay, none of the overloads of the template standard array are callable using argument types void. Wow. Okay, very nice. Okay, so we don't want to use the word array like that, probably. We probably can't do that, though. We probably want to say int array. Right? Probably want to say that here as well, maybe? Maybe it's okay. Let's see what it says. Assertion failure. On 44. Well, these don't look good. I'm going into a rabbit hole with this one. This is getting bad. I think the problem that I've run into here already is that I'm trying to guess more different things. Like how to do all sorts of different things. You know what? It's fine. It's fine. We'll get through it. We'll get through it. It's taken a while, though. It is taking a while. Yeah, I don't know what's happened here. Assertion failure. These look bad, I think. Like, what is happening, actually? Okay. So, here, let's disable these again. Oh, now it says passed. Okay. Let me add a couple more tests in here, then. But, I mean, are we sure that this ran? I'm not sure yet that this ran. Okay. Expected now equals 1, 0. Actual now equals int to digits 10. Okay, now if I do this, I think it's going to come out backwards, right? No. No, I think it should be okay. I think it should be correct. Let's copy this. Oh, okay, so now we fail. But this failure looks nasty. Like, what the heck? Why is it like this? This is crazy. This is really ugly. I don't understand what it's trying to tell me. It says the line number at least. Right? So it is here. So like can't we show something the actual and expected? What are we what are we showing this for? This is not good. Oh man. Okay, so I really feel like I want to do this at like a REPL or just hold on. Hold on. We need to go back to the hello world or the getting started. We need to do something different. We need to find getting started and okay. Yeah, let's try dub. Okay. where do I want to put this file? I guess it really doesn't matter. I just want to get something done. Okay, so test file D. Okay. All right, so that looks fine, I guess. So now if we go into here, and then let's see if I remember how to open this. Okay, so all right, so we don't want this. We want whatever we did here, right? Okay, so here, I guess that's fine. So then we'll say auto 10 digits equals int 2 digits 10. Write FLN? Why FLN? I'll just try it. I don't know. Write FLN 10 digits. What's it going to say? It says, cannot implicitly convert expression of type string to immutable int. And that is on man, okay, so it's 29. Okay, so we can't write that. Oh, shoot, I did not mean to click. Okay. Where's my spec again? Was it this? Okay, so write FLN. So this is write F with a new line. Okay, fair enough. And then for write F, we can do a format string. And if, okay, hold on. Format string write int array, I guess. Array. Oh my gosh. D programming language. So to do this, we want to pass a format and a something. I don't feel prepared for this, but let's try. So S, no. Oh, okay, that's better. And hey, look, they did come out backwards. So that's what I that's what I was concerned about, and I was like, maybe it won't, but they did. They did come out backwards. Okay, so Cool. You think we can just, like, reverse an array? Reverse a range? Okay. No property reverse. Okay. Okay, well, let's just reverse it ourselves then. I don't know. So we'll go int e equals this, and then we'll say for int I equals a length minus 1, I greater than equals 0, I minus minus, and we'll say b squiggle equals a sub I. Okay, so that should reverse it. Cannot implicit a length minus 1 of type ulong to int? Okay, so if I just say it's ulong, is that okay? No? Out of bounds? Okay. Oh gosh. Okay, equals a length minus 1. Uh-oh, what was a length here? I really need print debugging or some form of debugging. Okay, so we can't say pure. That's crap. We need to say import standard stdio write fln, and we need to say write fln s and a length. Yeah? Okay, so it wrote 2 as the length. So far, so good, I guess. I greater than equals 0. I minus minus. Did we go one time too many? How did this happen? We went 1 to 0. I mean, that seems okay. It seems like, oh no, yep, there it is. It did go too far. It did, in fact, go too far. And now we see the problem, because when we minus minus, it's still greater than or equal to 0. So u long is no good. So, can we cast? Cast like this, maybe? Will this be allowed? Let's see what it says. Cannot implicitly convert. Well, I tried to explicitly convert. Let's see. Typecast. That's not it. Cast. Let's just look cast expressions. Cast. So we use the cast keyword. cast minus P to type foo. Okay. Yeah, that's more like it. That's more like it. Okay, I feel a lot better now that I've got some weirdness out of the way, which should never have been weirdness. I'm really weird about some of these things all the time, man. All right, so we can do that. All right, so now let's go back to the source file. And so we know that we're going to have to reverse it. Oh, let's see. Like this, right? Okay, so now if we test, it says undefined b, which we're going to say int array b Okay, so it passed that. Let's do, I think one more should be sufficient, I guess. So, for now at least. So let's say expected equals, let's not do this. Let's say we'll have a 6, 4, 3, 7, 2, 8, 3, 3. 6, 6, 3, 7, 2, 8, 3, 3. Let's see what it says. It says okay. So there we go. So we're good there. I spent a lot of time, and I feel like I learned basically nothing. I don't know. Maybe it's just warming up. Maybe I'm just warming up. All right. So let's go back to what we actually did here. So we turned it to string. This time we're not going to turn it to string. We're just going to get the digits of it, I guess. And then we're going to sum of those digits using this pow. And I'm pretty sure, yes, I did see in the docs that this star star is used for pow there, so that's awesome. So I'm going to say auto digits equals int 2 digits number. Okay. Then I'm going to say int sum equals 0. Okay. And then I'm going to say for int I equals 0, I less than digits length, I plus plus. Okay. And then I'm going to say sum plus equals, and then I'm going to say digits sub I, and then I'm going to say star star, and then I'm going to say digits length. And then I'm going to return sum equals number. And hey, you know what? That might actually be the whole solution. Let's see what happens. It says error. Okay. I thought I saw that somewhere, but perhaps not. Let's see what I actually saw. Where are operators? Okay, attributes, expression, statement, order, unary, mul, division, floating point, pow, 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 pow. Oh! Okay. I completely misremembered what I'd seen, but that's cool. I like it. So we're gonna go caret, caret. Yay! Love it. That's so great. That's so great. Dub test. Hit me with it. Okay, so something passed. So now let's turn these tests on. And it says passed. So now if we do exorcism test, does that do the same thing? No. That's okay. The dub test passed, so let's try just submitting. I'm not sure, but let's just try. And I do want to move on. I do want to move on, so let's do it. Armstrong, numbers, D. Okay, that's not it. Yeah? Okay, let's see what happens. I don't know that I'm confident. Oh, it says passed. Okay, let's move on. Move on, move on, baby, move on. That one took me forever. All right. For no good reason, it seemed like. Actually, hold on. Am I happy with this result at all? Int 2 digits. This is such... No, I mean... I think the result is fine, but it should never have taken me that long. Let's go to the next one. MIPS. Okay, so here in MIPS, our solution is ultimately, I guess, going to be pretty similar. Okay. To what we did there, because in D, I kind of ended up doing it with just sort of like basic like math manipulations, kind of. So in MIPS, it might be similar. Let's see. One difference is I think that in MIPS, we probably do not have like a POW option. What was the other one I did in MIPS? So we did leap, which is kind of a basic math. Let's see what that looked like. Implementation.mips. So this is what it looked like. This was a while ago. So let's see if I can understand at all what we've done here. So I defined several functions, or subroutines, I guess. And that seems fine. So what is li? I think that's like load integer, maybe? Let's look again at the MIPS. MIPS ref PDF. This is a good place to start. Okay, so here's li somewhere. Where is it? Li. Load immediate. Okay, cool. So into the output, we put 1. And then we JR. So JR is jump register. Okay, so that goes back. Interesting. So is leap year, multiple of 400. Okay, okay. So let's go through it. So we come into is leap year, we load immediate, so then into this temporary register, we put a 0. And then in the second temporary register, we put a 4. I guess, right? Okay, so far so good. So then we do a division of whatever they put in. We're dividing that by 4. That's what we do to start. Okay, cool. Then what's MFHI? That is move from high. Oh, yes. Okay, because when we do the division, something comes out to high. Where does it say? Okay, so high becomes the RS mod RT. So that becomes the remainder. Okay, so we found the remainder and we put that into one of our temp registers. Okay, sure. All right, so now we're gonna break. So B equal is break if equal, right? Or excuse me, branch if equal, whatever. All right, so we said we're gonna branch if equal. So if this remainder came out as 0, then we're going to say, is leap year multiple of 4? And I helped myself out with a comment. If it is equal, then the year is a multiple of 4. All right. So then we load immediate. So this is our output register. and we put a 0 there, because in that case we were saying, hey, it was not a leap year. If it was not a multiple of 4, then it was not a leap year, and that's it. And this $RA is the return address, I believe, right? $RA. Does it explain that that's the return address here? I think I had to read that somewhere else. All right, so then, so what did we do here? So in this temporary register, we put 0x. So this is the number 100, right? 64 in hex, I believe, is 100. Should we check that? So if we go number parse int, oh yeah, right here. Parse int 64 in base 16, it's the number 100. Okay. So then we divide, and so what was A0 again? That's our input. Okay, cool. And we divide that by 100. Okay, so then we get the remainder. And if we found that the remainder was 0, because 0 should still be in our register there, then we say, is it a multiple of 1? Okay, so let's stop looking at that. That's good. Let's look at the one that we're doing now, Armstrong numbers. So I think that this one is going to actually be a little bit longer than the leap year. The leap year is a very simple calculation. Armstrong numbers is also a simple calculation, but not quite that simple. All right, so let's go into Armstrong. So let's take a look at the help here. I might need some help. It's going to be, the solution is going to be pretty similar to what I did in D, ultimately, but syntactically it's going to be pretty different. So this is how we do the tests, apparently, so let's try it. Java jar. Oh, what is our path to Mars jar? Hold on. I can probably auto-complete it. Let's see. So we did Java. Oh, okay, so there it is in my downloads. NC. Okay, so let's see what that does. Failed for test input 0. Expected 0 to be... Okay, fair enough. So that seems to be working fine. Oh, Mars Simulator GUI. I never tried that before. I don't think I need to try that either. I'm just going to move on from that. It sounds cool, though. Mars Simulator GUI. I might want to try that sometime. Not tonight, I don't think. All right, so let's look into our file. Implementation.mips. What's in here, baby? Okay, so global is Armstrong number. Okay, and that's our subroutine. And so then this just returns. We see that we have an output register and an input register, and we're able to use these temporary registers as needed. So same as we had for leap year. All right, so what will be our first step? So first of all, I think it's going to be similar to what we did in D. So I'm going to copy the D file into this file, right? So let's cat D Armstrong source Armstrong numbers D into my MIPS file, right? So that we have that to reference. Okay, so let's look at it again. Okay, so now here we are. Let's comment all of this out, first of all. So let's go all the way down. And then how do we comment out? We go like this. Okay, so we comment all that out. All right, so do I need to know that information? No, but this is good. This is good stuff. Don't need that. And then, of course, don't need any unit test information. Okay. Okay, yeah, let's leave that. So that's is Armstrong number. Okay, so let's start by, I don't think we have a power, and we're going to use a power. So let's implement the power subroutine. So, oh, do we have to mark it with global? Let's see what we did in here. So I marked global is leap year, but the others are not globals. They're locals, I guess. Okay. Okay, so we've got is Armstrong number. So then let's do a POW function, or subroutine, or whatever. Okay, POW. So we know we're going to have to finish like this. So for the output, there's a V0 through V1, apparently. So do I want to use V1 for the output register for this one? That might be fine. We'll try it. Let's put that as a comment. Using V1 for the output register for... what are we using for the input register for POW? Do we have an A1? We have an AT? Oh yeah, A0 through A3. Okay, so let's put that. Using A0 for the input register for POW. Cool. Yep. All right, so then how do we actually do the POW? We have to make various like multiplications, right? Oh wait, no, not A0. It should be A1. And we need two input registers, right? So the first one is for the let's see, base to the for the base register, base input register. Okay. Using A2 for the exponent input register for... We do that? I guess so. Okay, so that means that we have to do like multiplications, right? So if B, or let's see, if A2 is 0, then we have to return 1, but actually we don't need to worry about that for this problem. For this problem, we needn't worry about exponent 0. Only exponent 1 plus. Okay. So at whatever point that A2 is the number 1, then we set V, then we jump to the return address, right? Except no, this is the original return address. So we need to, I guess, do something different, right? So I think that's something I never did in the other one. Like here, we just return out of the whole thing whenever we find one of these, right? So like, if we need to go in there, then we go in there. And if not, we just jump back out of the whole thing. So that means I need to figure out how to set. So jump and link register. Okay, branch if greater or equal. Move register. No. I think this is the one we need, right? Jump and link, I guess. Okay, so let's look at MIPS, jump, and link. Yeah, this will be good information. Okay, so jump and link is a go sub, right? this saves the return address in $RA should you wish to return from whence you came. Okay, well that's good, but that means that if we're going to do that, we need to put the original RA somewhere else before using the... Okay, so let's say, first things first, let's save the original return address. Okay, so that's where we will say copy, which is, it's not load immediate, it's load... what is it, load? No, these are all immediate. We want to copy register. And where is that? Set load linked? No. Wait. So load immediate, okay. Load address, and we put label. So that's not it. So this set, okay, so load byte or whatever, immediate RS. And immediate RS, does that mean that it's going to be whatever is in the register that we specify? Did we copy anything in the other one? Looking at this again. So we did load immediate, we did div, moved something from high. So where's move from high? Oh, move register. Move from high, move from low, move register. I would think that that would copy, maybe? Okay, let's look. MIPS, move register. Copies a value from one register to another. Okay. That's the one I want. Yeah! All right, so we're going to say... move RA, and let's put that in our T9, where we can use that, I guess, right? Sure, okay. Okay, so what is our next step? We've got to get all of the digits, I guess, but where are we going to put them? So if we need to put a bunch of digits, they are not going to go in registers, they're going to go in memory, right? Presumably. And once again, in the previous one, I didn't use memory at all. Okay, so we're going to have to store something, I guess. Okay, yeah, so these are all referring to memory, right? So are we going to use SW to store something in memory? And that's what we're doing here, creating an array. Okay, so another thing we can do is we can, one nice thing about this is we can kind of automatically reverse, not automatically, but like when we store each digit in our array, and I guess they should probably just be bytes because we know that they're just going to be digits from 0 through 9. So when we store each one in the array, we have to keep the address in a register, and we increment that, and then when we get them back, we'll just decrement the same register, I guess. Is increment and decrement here somewhere? Or do we just have to do add immediate? Add immediate is fine. Okay. So, man, I think this is going to take me a while. So here we go. Now we will put the digits of the input into memory. Okay. So let's see. So when we pick a spot in memory, how do we know? Do we know like which spot in memory to use? We have to be careful, right? Because we can't be like overwriting source code somewhere, right? So let's see. So we're going to branch if equal. Okay, so we're going to load immediate. We'll say T0, and we'll say 0, right? That's kind of how we did it here. 0x00, load immediate. Okay. And then we're going to div, right? And that will be $A0. Do we need to save it? Not really, right? Div $A0, $T0, okay. And then we're going to move high to get the remainder, right? Move from high. MF high, dollar, and it just takes some register. So we'll put that into $T1. Okay. So now, branch if equal, right? Where's that again? Branch if equal, and we'll say $T1, $T0, and then we have to say where we branch to. So if they are equal, then I guess we'll go to the next portion of whatever we're doing. So I guess that's going to be like summing. So we'll jump to summing, right? Okay. So then, okay, so then if they're not equal, then we're going to jump back, basically. So do we need a label up here to show that we're going to jump back somewhere? MIPS label. So we can put a label wherever, right? I think. So I'm going to put a label here. 2 digits. So then here, we are going to jump Yeah, so we'll jump 2 digits, right? Okay, so here, let's say, okay, if the remainder is 0, we are done getting digits. Okay, so now we did this, but now we need to put, like, the actual digit. Oh, wait. No, no, this is wrong anyway. This should be MF low, because it's not the remainder, it's the quotient. So now, here, we have to put the remainder into memory. I don't know, this is a pretty fun one. I need to take a 5-minute break, so I'm gonna say BRB. All right, and I'll be back in like 5 minutes probably. You notice how the less familiar the syntax is to me, the more basic, dumb mistakes I tend to make. I don't know, I call it like a working memory thing. I don't know if that makes sense. I don't know psychology. But whatever it is, like, the cure is to just learn the syntax really well. Anyway, so, like, I divided this by 0, and that's insane. So no, we can't do that. So let's load li t1, the number 10. Okay, there we go. Okay, much better. Okay, so now where does the memory go? How do we set aside memory in MIPS? How to set aside memory in MIPS? It doesn't even have to be dynamic. In fact, I don't want it to be dynamic. They keep saying variable size, but I don't even know how to do it in fixed size. Let's say fixed size. No, I don't want variable. I want fixed. Let's see what this is. It's funny that they say this thing about novice programmers, because, like, I was doing assembly, well, I guess, yeah, like, when I first started in school, but whatever. Uses the SP register. Let's take a look. SP, that's our stack pointer. Okay, cool. Let's use the stack pointer. Yay! So we're going to store, where was it? Store byte. We're going to go SB. Can we use high? Can we just move it right off high? I guess maybe not. Okay. So MF high. Let's use $T3 since we haven't used it yet, I guess. And then we will SB, and then we will put $T3 into where the stack pointer is. Okay, so we're putting $T3 into the memory location pointed to by SP. Okay, so now do we have to increment the stack pointer? I'm guessing we must, right? And we just increment it by 1, I think, because it points to bytes. And does it explain that here? I think it does, right? (32-bit flat memory). So wait a minute. So is each address a byte? Is, I guess, what I want to know. I believe it is, probably. What's the next page? Ooh, cool, cool. I actually think this Armstrong numbers program is probably a little bit more difficult than the programs. Oh, MM is cool. What you're working on? What are you building? Well, okay, I'll show you. I don't know if I missed your chat before, but I'll show you. So we're doing exorcism, and the challenge is called 48 in 24. And for the how the challenge works is they have different programming languages, right? So we've done, I don't know, a bunch, but there are still lots and lots left. So today I did JavaScript, and the puzzle is very simple. It was just like doing this, basically, just adding some things that were like raised to the power of the length. It explains it here. So 154 is 3 digits long, so that's what they did or whatever. So anyway, so I did the JavaScript. I decided today I'm working backwards. And then I did D, and the D solution is basically what I put into here to reference because it was a little bit more complicated just because I don't know how to do anything with the D programming language. It was the first time I ever tried it. And now we're doing MIPS, and so that's fun. So let's see what we have so far. So first things first, let's save the original return address. So I put that in the temporary 9, I guess, so that we can go there when we need to. Now we will put the digits of the input into memory. So I have a label here that we're getting to digits. I put a 0 here because we're going to compare, and a 10 here. And then we're going to divide our number by 10. But that's not even really right, actually. I'm going to have to change that because this is going to keep going down. If the quotient is 0, we are done getting digits. So really, before we do this, whoops, we should say that we are going to copy our original input to T1, I guess. And then this is going to be dividing T1 by T2. Nope, I already used T1 for 10. This should be, okay, let's say this is T4. So we're going to divide T4 by T1. I don't know why I have a T2 there. Okay. So then, wait a minute. So then I move, okay, so yeah, I move the low to T1. Why am I still using T1 here? T1 is supposed to be 10. This should be T4. Okay, so now there we go. So now we have the quotient in T4. All right, so this is the quotient here. Okay, so if T4 is 0, then we'll go down to summing, which is going to be another a local subroutine, I guess, which we're going to get to. All right. So then if we have, okay, so we'll take the quotient. The quotient is on high, and that's what explains here. So div high becomes, oh no, wait. High becomes the remainder. Okay. So here, so low becomes the quotient. Right here, low. So we put that on T4, then we put the remainder on T3, I guess. So then we stored the byte that we had on T3 onto wherever the stack pointer was. Okay, so now we have to increment the stack pointer. So I'm going to put a 1 somewhere. So we haven't used T5 yet. And then I'll say that will be a number 1. And then we will add. Okay, so we'll put the stack pointer, we'll have 1 added to it. Add SP, SP, T5. So I put 1 on T5. Sure. Okay. Okay, so then we'll say here, incrementing the stack pointer. Okay. All right, so if I go back and reference, have we left anything out? So we're saying while x is greater than 0, we put that on there, the remainder, and then we put the quotient back. Okay, yeah. So I believe that that part is like as it should be, basically. So we jump 2 digits. Okay. And so now we're going to go branch to summing. And the good thing about this is we don't have to go back because we're done. And we have the digits supposedly on the stack. Okay. So now when we sum, we have to do the POW. So I haven't done the POW yet. Okay, so summing, we have to go, so we'll start with a sum. Start by storing the sum, starting sum 0. So let's put that in T6. So we'll say load immediate T6 0. Okay, so that's our sum. Let's put that. T6 is our sum. Oh, but you know, that doesn't really make sense because... Oh, wait, yes, it does. That's fine. The Boolean output will be at the end. Okay. All right. So then... we need to go through each of the digits. Oh, I didn't store what the stack pointer was at the beginning. Let's also store the location of the stack pointer so we know how much is on the stack. Okay, so that will be move SB, or SP rather, and that will be T8. Okay. All right. Then what's the next part here? Okay, so now peeling each digit off the stack one by... Okay, so we're gonna say BEQ stack pointer with T8 where we stored the original. And so if that happens, then we should be done. And so I guess I'll just do a done subroutine somewhere. Let's say done summing for when we're done summing. Okay, so then so we incremented the stack pointer each time regardless, right? So we're gonna decrement that. So we're gonna sub, and let's see. So when we sub, we put rs minus rt into rd. Okay, so stack pointer, and we'll subtract 1, which is $t5. Okay. These should probably all be before that. Okay. Okay. All right, so now that the stack pointer points at the digit, let's load the digit from memory. Yeah, I probably have to do that. So we will load byte, so LB, and we will take it from off the stack pointer into, I guess, one we haven't used yet. So $T7, $SP. I think so. Load byte. Yeah, should be. All right. Okay, so now we have to raise the digit to the power of the number of digits. So that means we need to store the number of digits first. Next, store the number of digits. Okay, so that will be, I guess I've used all of these temporaries already. All right, is there one we don't need anymore? Do we not need T1 anymore? I don't think so. We can use T1 here since we don't need number 10. Okay. Okay, so we will sub, and we're going to put it into T1, and it is going to be stack pointer minus T8. Okay. Yeah, that seems right, I think. Okay, so now we have to raise the digit to the power of digits. So here we jump and link pow. All right, so now let's figure out how to do the pow. So here we still should have a number 1 in T5. Okay. So let's put that. We should still have number 1 in T5. Okay, so we will say BEQ $T5, and so we're gonna have to set these before we go into POW. Let's do that now. Oops. Okay, so we're going to, let's see, $A1 needs to be the base, and so that's the digit. The base for the POW subroutine will be the digit, and the exponent will be the number of digits. Okay, so we are going to move, and it's T1, and that's going to be into A2. Okay, and here we'll move the digit, which we think is T7, I think. And that will be $A. Okay. All right. So if 1 is the exponent, $a2, then we jump out. Oops. Did I put caps lock on? Okay. So far so good there, I guess. So I guess we don't need this JR. Oh, wait a minute. BEQ, can we put a register in there? No, it has to be an immediate. Okay. So I'm going to put a label, pow done, here. And this will be pow done. Okay. And then that jumps to, okay, cool, the return address. Okay, so this will be a label pow start that we'll need to be able to jump back to. So then we need to store. So we need to move $A1 to $V1. And we actually need to do that before we even do anything. So move $A1 to $V1. Okay. All right, so now we need to decrement the exponent. So we're gonna say sub $A2, $A2, $T5, multiply the result by the base. Okay, so when we multiply high, oh wait, does this mean both high and low become RS times RT? I think so. Okay, so we'll do mult, and we will do, or is it high and low together that become the product? Let's see. MIPS mult instruction. Let's take a look. So, okay, so mult, the result, if you want the result back in $V0, okay, so the 32 most significant will be held in high, and the 32 least significant will be held in low. So since the base is going to be a digit from 0 through 9, then I don't think we need more than 32 bits. I guess unless it's really long. We'll see. We'll see. Oh no. Okay. Note that the if the result ends up more than 32 bits, the most significant bits will be in high. I'm gonna kind of hope that that doesn't happen because that'll make it a little easier for me. We'll see if it happens. All right, so we're gonna multiply the result, which is $V1, by the base, which is $A. Okay, and then we are going to move high, MF high, is that what it is? MF high, oops, or was it? Yeah. MF high, and that will go to $V. Okay, cool. Oh, no, this should be MF low. MF low, because the least significant bits should be in low, they said. Okay. So then, so when we get to here, we have to jump back to pow start. So we'll say jump pow start. Okay, so then we'll come back. We'll say if this is that way, then we'll say done, and we'll come back. Actually, yeah, that seems like it's probably about right. Have I left out anything obvious? Let me think it over. Okay, so we have a base, which we set to the output. Or we set the output to the base to begin with. So then we have a loop. First of all, we say if the exponent is 1, we are finished. Okay, decrement the exponent. Multiply the result by the base. Yeah, I think that's basically it. So then here we put the digit into here. We put the exponent to here. And we went to pow. So then pow should jump back to the return address. So now in v1 we should have the power. So now in v1 we should have the digit raised to the power of the number. All right, cool. So now we have to add that to our sum. So we're going to say add. We're going to put into T6 the sum of T6 plus B1. Okay, cool. So that's summing. All right, so now we're going to have to jump back to here. Sum loop. And so here we will jump sum. Okay, so then when we get in here, so then here we'll say done summing. So when we're done summing, we're going to say, now we have to compare the sum we added up to the original input. 1 if equal, 0 if not. Okay. So we're going to say BEQ. The sum that we have should be in where did I say I put it? T6. Let me put that note. Note. T6 is our sum. Okay. So if $T6 is equal to our original input, which was $A0, then we branch to is Armstrong true, which we can put here, is Armstrong true. And so then this one will load into V0. So we'll load immediate V0, the number 1. And then we'll jump to where we put the original return address to T9. Jump, register, T. Where did I put the Z from? Okay. All right, so that's what we do there. And so then if not, we will say li $v0, 0x, 0x, 0, 0, and again, jr $t. Yeah, that's a lot. I don't know where all the mistakes are likely to be. Let's see, why did I end up with some extra spaces in here? I do not want any of that. Oh, yeah. So jump 2 digits here. If the quotient is 0, we are done getting digit. I don't think this is... All right, time to see how to debug probably, but let's see what we get. Error SB, too few or incorrectly formatted operands. Well, at least that's probably easy to fix. Where did it say it was? On 25. So I've got SB. So that's supposed to be store byte. We're supposed to put a register, which is what we're storing, $T3, okay. Then we're supposed to put an immediate RS. Uh-oh. I hoped the stack pointer would just work, but no luck. Okay, let's see. MIPS store byte instruction. Okay. So they did SB. Oh, they put a 6 there. $S3 plus 6. Oh, okay. Fair enough. And I think that's exactly what they said here, and I just didn't understand it, so I ignored it. But that's good. Okay, so I'm gonna put 0 like that. Okay, so then there was another one which was LB on 41. I think it's the same problem. Let's look. Load byte. Okay, so again. Okay. Let's try it again. Okay, it says runtime exception, address out of range. Okay, null pointer exception. Nice. Okay, so we got to line 25. Oh, interesting. Address out of range. 0. Okay, so do we have to, like, initialize the stack pointer? I guess probably. So MIPS initialize stack pointer. Let's take a look. Okay. So they're using the stack pointer here. Add IU. Allocate 2 words on the stack. Add IU. Add immediate unsigned. Huh. Okay. That, all right. So I'm just going to allocate something onto the stack. I think I can allocate a whole bunch if I want. Probably. But like I'm not going to have that many digits. Like if we go number max safe integer, like I don't think we're going to have any more digits than that, right? $16. So we really only need like 16 bytes, really. All right, so I'm just going to try doing what they did. Add IU, stack pointer, and then put immediate -8. I'll put 16 because it's going to be up to 16 digits, but this says words, and we only need a byte per digit. So it's fine. So let's try it again. Um, Now I guess we must have to allocate some memory on the stack as per, yeah, sure, as per this answer. Copy link. Okay, so we're gonna say add IU $SP minus 16 up to 16 digits because that's how many are in my Java. Save. That's not a very good reason, but whatever. Let's see what it says now. It says address out of, no, it still says the same thing on 29 this time now. So null pointer on, okay, so we tried to store something. Wait a minute. Okay. Address out of range. SB, so it's on 29. Oh, okay, so yeah, it is the same place. Oh, interesting. So when they went to store something, save this in the upper word. Okay. Yeah, so this isn't what I needed to do. The stack pointer is at 0. That's the problem. So trying to subtract unsigned from it did not help. All right, let's look it up again. Initialize stack pointer. MIPS. Okay, let's take a look. Whoa, this is a nice looking site. Oh, heck yes. I guess I'm just hoping they'll tell me where I should put the stack pointer to begin with, but I don't know if they're going to tell me. There was sort of like a diagram thingy. Actually, that might help. So it says MIPS and memory. So in this diagram, they say the stack should be at 0x7FFFFE00, right? So that's the number we should use. Oh, that's the address range, right? So the start of it is 0x7FF. Okay. All right, so I'm gonna try using this address for the start of the stack, I guess. Let's just see. Okay. So we don't want to do any of that because it didn't work. Let's initialize the stack pointer to the start of the stack as per, oh, that's a long one. As per the intro book. Okay, so then we're gonna say li, the stack pointer, 0x7FFF. Okay, now let's see what it says. Okay, no, it still says the same thing. Okay, so I don't understand what it's saying. Runtime exception, address out of range. Okay. MIPS runtime exception address out of range. I thought I had some idea, but I did not. Okay. Syscall? Uh-oh. Syscall. Syscall codes. What syscall code are they using? Space for new words. So whatever is in V0, is that what's happening? Oh, no. This was -1. Okay. Read name, save name. System call. We can do these system calls, apparently. But I don't think I need any of these. Oh, wait a minute. What's this? SBRK allocate memory. Okay. MIPS syscall allocate memory. Uh-oh. Yeah. To allocate space on the heap, a system call is required. Okay, but I wasn't planning to allocate space on the heap. Okay, so let's see what this one did. So give 4 bytes to the stack to store the frame pointer. Let's try printing integer. Yeah, let's try print integer to print what is the stack pointer. So apparently they're using $V0 for the output, but it looks like we also have to use that same thing for the syscall. All right, well, whatever. All right. So that doesn't make sense, but before storing the location, let's print it out to see what we... Okay, so we're gonna say li $V0, and then it's 1, it said, to print integer, so 1. So 0x01, I guess. And then we're gonna syscall. Oh, but when we go to print integer, what integer does it print? MIPS syscall print integer. So, shoot. Okay, so we try, hold on. Okay, so we tried to print, it was in T0, it looks like. Okay. So is it LR for load register? Or no, it's move, isn't it? Move SP T0. Yeah? So okay, so they put it here. So I'm going to say, looks like T0 will be the integer printed per here. Okay, let's try. Okay, so it did print a 0. Okay, so the stack pointer is at 0. Man. Okay. The stack pointer, I guess, is not supposed to be there. Okay, so let's try again. Um, let's set the stack pointer to where we think the start of the stack should be. So we're going to say li into sp, we're going to put 0x 7fm. Okay, so let's see what it does this time. Nope, it still says 0, so that's not good. Darn. If we move something else, like the return address, for instance, can we print that out? Try printing return address. No, that one came out 0 as well, it looks like. I must be doing something very wrong. Okay, so this one came out 0. Maybe that's fine that it came out 0. What about the number 1? Error? Oh my gosh. Invalid. Oh, hold on. Wait, am I doing move wrong? I must be, huh? Where's move? Move register. Oh, but it doesn't... Does this really explain it? Okay. MIPS move. I'm not getting very far tonight. Oh my gosh. Okay, so move so destination is before source. Okay, let me put that. Important note. Usage note. Move dest source. Okay, so every place I have move, I did it wrong. Yep. Okay, so this needs to be $T9 first, and not that. Okay. Where do I have it next? Right here. All right. Wait, what was that? $T7. Okay. Move too few or incorrectly formatted. And that's on 25. Okay, let's see. Oh, yep, I got rid of one. Now we will put the destination. What was this one supposed to be? So we have T4, which is is going to be what we divide by. So T4 is supposed to be our input. Oh, interesting. Oh, there's our 7FFF. Okay, well that's better. I still see 2 zeros, which I don't think is good. Address out of range. 7FF. Interesting. Okay, so if we go back to the book, I very probably misunderstood what it was supposed to be saying. Okay, so we want 7FFF FE00. Right? Or no? Okay, so reserved here. Interesting. Okay, so FE00. Let's put that on there. All tests passed? No way. No way. I'm so happy. I Wait, I don't know if they all ran. Let me get rid of that output syscall. Okay, so did all the tests actually run? Let's take a look at the runner. I'm gonna submit. Let's take a look. Let's see if it passes on the site. Oh my gosh, I'm very excited. Oh my gosh. Easy. I guess it was kind of easy in the end. Sorta. Kinda. I don't know. Processing? There's no way. What is it gonna say? It's gonna say, no, you are so dumb. No, it says passed. Amazing. Amazing. Okay. Let's look it over again. This is what we did. Oh my gosh. That one took me a while. Oh, let me get rid of those comments at the end. Actually, you know what? I'm just gonna leave it. I'm just gonna leave it. So, very exciting. Very exciting. I am pumped. Okay, I'm gonna move on to another one. I should have time, maybe, if it's not too hard, for whatever the next one is. That was not too shabby. I am excited. Let's go to Kotlin run length encoding. Okay, join the Kotlin track. Here we go, baby. Okay, local. Let's take a look at the tooling requirement. JDK and Gradle. I think I likely have those already because I think I needed them for Groovy, and I mean, I think I have. So let's just try the Hello World and see what we get. Okay, let's go to Kotlin. Hello World. Okay, let's see what happens if we try the test. It says, oh, okay, permission denied. So let's add, oh, wait a minute. Okay, so Gradle W is there. Let's add a executable permission to that. So we'll say chmod. Oh yeah, just like that. Okay, let's try again. All right, a little slowish. I like the programming languages where all these processes just go so fast. Like D, even D, like, once I got the right compiler, D seemed to work fast. I liked that about it. Whereas this poor Gradle is rarely fast. Oh well. My goodness, a lot of configuring, huh? I guess it probably won't do this every time because it said it was downloading like a Kotlin compiler or something, I think. So I guess it's understandable that it would take a while then, right? I'm not sure if that's really what it said. I thought that might have been what it said. I wasn't reading closely. All right, cool. So let's now try editing our files. So we'll go into source, main, Kotlin, hello. Okay. Hello world. Let's try the test again. Hopefully it's not slow this time. Okay. Let's submit. Okay, let's see if we did that right. I think so. Pretty slow processing on their site as well. Darn. Darn you, Gradle. I'm just gonna keep reloading. Oh my gosh. Come on. Okay, mark is complete. All right, so now we are gonna go to the run length encoding. And we're gonna copy this. Okay. See if we can finish this one. I'm kind of doubting it at this point, but I'll give it a shot. Okay, let's take a look at our README. Okay, this is what we need to know. Run length encoding and decoding, all right? Run length encoding is a simple form of data compression where runs of consecutive data elements are replaced by just one data value and count, all right? So in this example, we have like a lot of W's. So instead of putting all the W's, we just put 12W. Okay. Then we put a B, sure. Then we put 12W again. This time we put 3B. Okay, sure. 24W and B. All right. That's cool. It's a lossless data compression. So in this exercise, we are going to have the letters A through Z and white space, okay? Will never contain any numbers, and numbers inside data to be decoded always represent the count for the following character. Okay, I mean, sounds pretty simple. I've never tried Kotlin really. So yeah, I've never really given Kotlin a proper try. I feel like I could I finish this more easily in Elm? I don't know. Let's just do the Kotlin. Okay. Okay, so here's what we have in our file. It says object run length encoding. It has an encode function, which takes a string and returns a string. And it has a decode function, which similarly takes a string, returns a string. So that's cool. That's cool. So I feel like it's sort of like a regex kind of thing, right? So is it? Because like, let's see. If we have, do we do it as a regex kind of thing? Like, I think it is, but I think it's a regex thing that I don't do that much. Let me just take a look here. Under the quick start. So I don't, usually use like back references very much, right? So let's try doing it with a back reference, right? So if I have some string, which is okay, so I'm going to say s match, I'm going to put a regex, and I'm going to try it with a back reference. Honestly, I think I've never tried it. Like, I've known about it and never tried it for whatever reason. Okay, so let's do it very similar to what they've done here. We'll see how this goes. All right, so why is it \k? Let's take a look. And can we do this in JavaScript? It doesn't say JavaScript here. Okay, we'll see how it goes. All right, so I've got some C, which is just any letter, I guess. Could be case insensitive. Okay, I lost the S, so invalid named capture. Okay, so I'm just gonna call this C. So I'm not gonna say equals, I'm gonna say that this part can repeat. Okay, so what do we think about that? Oh, let's say it can be like 0 or more. Okay, so that matches everything expected, right? So then I would say map, and each element of that would become e length and e sub 0, basically. And then we would join. So that would be like my JavaScript solution, right? We can do it nicely just using this regex. And presumably we can use a regex like this in Kotlin as well, right? So let's see. So do we think it's correct? Oh, you know, that 1 is actually not supposed to be there. So if the length is greater than 1, then we do length. Otherwise, we do nothing. Okay, so 5a, 3b, then we just put a and b with no number, and then 3a, and then b with no number. So that's basically what they did, right? In the README. So yeah, so this would be basically my JavaScript. Honestly, let me try submitting my JavaScript solution. So it's run length encoding. We would go JavaScript. Yeah, let's copy this and let's see. JavaScript, so this is run length encoding. So let's npm I, hopefully it won't take too long. Okay, so that's good. And then let's do, let's look at the spec real quick. Okay, so let's replace or substitute rather, xtest with test wherever it appears anywhere. And then let's do exorcism test. And it says 13 failed. Okay. Okay. So in here we have encode and decode. Oh, I did encode, but I didn't do decode yet. Okay, so it's not a skeleton file. We'll get rid of that. Okay, looks good. Okay, so what did we do here? We were just like, no, that's not it. We were just like s.match. We used this regex, which honestly just basically solves the whole thing. And it's very simple. But you know what? I like this because literally I have never used back references before in regex, which is weird. So that's cool. All right. So let's paste this in here. So we need to take some string. And then we're going to return, yeah, just that. Okay, let's see if the encode tests pass like that. Yeah, 4 passed. So we failed on encode empty string. Cannot read properties of null. All right, so if we did not get any match, then we need to pass back empty string, I believe, right? So we'll say s length greater than, let's say s and s length and s length greater than 0. Okay, so if that's true, then we'll do this. All right, so that's gotten really long. So we'll just put that there. And so if it's not true, then we'll just pass back empty string. Okay. Okay. So now 5 passed. Okay, cool. Let me prettier that. Prettier, right. Okay. Now, okay, so our failures are decoding, right? I believe. Oh, no. Encode with multiple white spaces. Oh, okay. So this does not have to be like A through Z. It could actually be, I guess, probably whatever, right? So let's say not that. Let's see if that's better. Okay, 6 passed. Cool. All right, so now for the decode. Let's do the decode here. So we have this thing. Let's store. All right, so temp1 match. So here we're going to match, we're going to possibly have some number of digits, right? And then we're going to have exactly one non-digit. We're going to match those wherever, so that's what we get. And so then we're going to map. And so now if we have digits at the front, we are going to want to match those. So we're going to say ematch some amount of digits, right? So then, so this time, let's say it's like this. So we'll say matches digits equals, whoops, I started trying to use Vim motion in the REPL here. Whoops. Okay, so matches digits. So then let's say if matches digits return and then we're gonna say match some non-digit, and so when we do that, take a look. So when we have some string like 5a and we go match some non-digit, it comes back with like this match thing, right? And so if we want the string, we go like this, right? Okay. So we go like this, and then we go repeat, and then we go number, and then we go matches digits sub-0. Right? So that's what we would return. Otherwise, we just return E. Right? So then we just join. And so that should give us back the original, right? Okay, so let me copy this. Delete here and paste. Okay, so I'm going to say that this is going to be S, and I will make this also S. And then, let's see, it looks weird the way it's formatted, or like highlighted, but that's probably okay. That's just prettier. Okay, there we go. Decode. Oh, they got rid of those parentheses. Okay, I didn't know they would do that. Is my music still playing? Nope. Okay, so let's try the test now. Okay, so now 11 passed. We're almost there. So then let's see. So then this one, decode empty string, and it says cannot read properties of null. So here we want to say basically the same thing we said before, right? S and S length and S length greater than 0. And then we'll say this. And then at the end here, we will say this. Prettier that. Okay, I think that looks fine. Okay, last failure. It says encode followed by decode gives original string, and we messed up because we did this. So we just need to get rid of this I flag. That was mistaken. Okay, let's try again. Okay. Nope, not that. Let's see what we get. And I am going to stop, so I guess I'm not really going to get to the Kotlin version of this. I am really happy because it's weird, but I have literally never used this back reference syntax ever. And I'm really happy that I've done this now, because that's cool. That's really cool. Yeah. So that is the solution. So I'm gonna plan to come back tomorrow. I mean, this is an easy solution because we're just using regex, so it should be just as easy in Kotlin and probably Elm as well, I would think. Yeah, that's it. I think I'll just go ahead and log off.